Welcome to this introduction to Lexical iOS. My name is Amy, and I'll be your guide through the wonderful world of building text editing experiences. This talk is split into three main sections. We'll begin by talking about what Lexical is, what are its goals, what does it do, and importantly, what does it not do. Next, we'll talk a little about how Lexical works behind the scenes. While it's not crucial to know every small detail of Lexical's implementation, having the main concepts in your mind is very helpful to understanding how to use the APIs. We'll also talk about the similarities and differences between Lexical on the web and on iOS. And finally, we'll go through how to get started with introducing Lexical into your app. Let's begin with what Lexical is. Lexical is a framework for working with text, primarily focused on building rich text editors. It's deliberately minimal. Lexical itself doesn't concern itself with things like UI components or toolbars. The logic for these features can be included via a plugin interface. The reason for this is to keep the core library tightly focused, but also because most apps want to design their own toolbar to fit in with the look and feel of the rest of the application. So if Lexical Core does not provide UI, what does it provide? Lexical provides a structured, extensible way of working with rich text, using an expressive set of APIs. Lexical's internal data model is a tree structure. You could make a Lexical heading node and embed a text node into it. Or you could make a paragraph node and embed multiple text nodes, each with different formatting. And then you could embed a link node, which in turn embeds another text node. All of Lexical's APIs are designed to work with and manipulate this node tree. There's no more need to enumerate string attributes to turn a paragraph into a heading. With Lexical, there's a quick and easy API to replace a paragraph node with a heading node. No more worrying about string ranges or off-by-one errors. Built on top of this rich API are various plugins. Lexical plugins can create new node types, new behaviours, import and export formats, and more. We ship some ourselves, and you can make your own. This is one of the strongest advantages of Lexical because plugins can be built to be drop-in reusable on any Lexical instance. Behind the scenes, Lexical is talking to TextKit. Our Lexical view wraps a UI text view behind the scenes, but the goal is to abstract away a lot of TextKit's more complicated concepts. When you're using Lexical, you should always use the Lexical APIs to mutate any state. This ensures that Lexical is properly tracking your changes and updating the node tree that I talked about earlier. I mentioned that Lexical began life as a JavaScript library for use on the web. Lexical on iOS is fully native Swift. We're not sharing code with Lexical JavaScript. We are, however, sharing concepts and APIs wherever it makes sense. If you've built some complex functionality using Lexical's APIs on the web, it will be easy to port it to iOS. Additionally, Lexical iOS and web can both import and export JSON in the same format, giving you an easy way to share data across platforms. Now let's talk about how Lexical works. We'll go through the fundamentals and contextualize them with what's going on behind the scenes. Lexical's data model is called the editor state. It contains the node tree that represents the current Lexical document, and it additionally contains the selection. If Lexical is just sitting there not doing anything, there is one editor state. But when you're in the middle of updating something, there will be two, an active editor state and a pending editor state. The pending editor state is the one that you mutate. We'll go into the details of this more deeply later. Nodes are discrete pieces of editor state. They represent the building blocks of your document, such as text, paragraph, heading, link, hashtag, etc. Updates are the process of applying changes. All manipulations to the state of Lexical must take place inside an update block. Transforms are a way of acting on an ongoing update. They let you make changes before the update is applied, so they can be useful if you want to add some kind of validation or restriction on what can be entered. Listeners are just hooks for responding to events in Lexical. Commands are our own internal pub/sub system that introduces a sort of priority, letting you intercept and change how events are handled throughout Lexical. To learn more about how Lexical works behind the scenes, let's dive a bit deeper into each of these, starting with editor state. The fundamental piece of editor state is the node map. Nodes have keys, and nodes are classes, and nodes have properties. And there's not a whole lot more to it than that. There's a root node, which encompasses your entire document. As you can see, the root node, and some of the other nodes, contain children. The nodes simply refer to the node keys of their children. So the nodes can be considered to be a tree, starting at the root node. When you're updating state, you're using the APIs that we provide to manipulate that tree. This could be another way to represent the same editor state. You'll notice that the editor state contains selection. Lexical abstracts over the selection, automatically synchronizing our selection model with UI text view's native selection. Nodes are discrete pieces of editor state. They encapsulate various behaviors, such as serialization, how the content should be rendered, and its behavior in the editor with respect to other nodes, like what happens if you type text before or after it. Lexical comes with some built-in nodes, such as paragraph node, heading node, text node, and so on. Plus, we have a bunch of plugins that you can install to get nodes for lists, links, and more. You can also create your own nodes. We have a whole session on making custom nodes, where you can learn more about what nodes can do. Updates are how Lexical tracks changes to its editor state, and then updates the TextKit view to match. As I said before, you're only allowed to make changes to the editor state from inside an update closure. Lexical tracks the changes you're making in a separate copy of the editor state. Then, when the update block is finished, Lexical runs a thing called the reconciler, which works out the diff between the old and new editor states, and then applies the same changes to the UI text view's backing text storage. Everything goes through this process. Even when the user types directly into UI text view, internally Lexical intercepts the keystroke, runs an update block, applies the changes to editor state, and then relies on the reconciler to actually update the text storage. In this way, the Lexical editor state is the source of truth, and the UI text view is just displaying a cached derivative. So the reconciler is doing the magic. The input to the reconciler is two editor states, the old one and the new one, or to use Lexical's terminology, the active and the pending editor state. And the output of the reconciler is a set of mutations to make to the NS text storage. We have deletions and insertions. The insertions are for attributed strings. So Lexical is converting the information contained in the nodes into an NS attributed string, and then telling the NS text storage to insert it at the right place. This is a big difference between Lexical on the web and on iOS. On the web, the reconciler is telling each node to apply its changes onto the corresponding element of a DOM tree. But because iOS does not use DOM to render things, we've built Lexical on top of TextKit instead. And nodes have to know how to describe themselves in terms of NS attributed string. You can learn a lot more about this difference in the session on themes and attributes, as well as the session on making custom nodes. I'd like to go into a little more depth about how Lexical works with the two editor states when you're performing an update. There's some clever optimization going on in there to make sure that Lexical doesn't do more work than necessary. When you start an update, a copy of the editor state is created, called the pending editor state. But this is not a deep copy, so it's a pretty lightweight operation. Remember that nodes are classes. That means they're stored by reference within the editor state. So the pending editor state references the same node objects as the old active editor state references. The magic comes whenever you make the change to a node. At that point, if the node has not already been cloned within this update block, Lexical clones the node and replaces the node in the pending editor state with the new clone, leaving the node in the old active editor state untouched. This new cloned node is tracked by Lexical. It has the same node key as the one we copied, so we know that it conceptually refers to the same node. But it's a new object. Lexical also marks it as dirty, so that the reconciler knows which nodes have changed. Then the change to the node is applied to the new cloned version. This all happens transparently. If you call a setter on any Lexical node inside an update block, then Lexical will automatically clone the node if needed, and apply the change to the new cloned node within the pending editor state, leaving the old node untouched. Likewise, if you read a value from a node by calling a getter, Lexical always pulls the value from the cloned node instead, if necessary. It all happens automatically and transparently when you're working using the Lexical API. Once the update is finished and TextKit has been updated with the corresponding changes, then the pending editor state becomes the new active editor state, replacing the old active editor state. We cleared the list of dirty nodes since all the changes have now been applied. And that's it until the next update. There's one more thing going on behind the scenes that I want to introduce you to. This is another difference between Lexical Web and Lexical iOS, and it's the thing that lets us know where to put the insertions and deletions that we're making to the text storage. This thing is called the range cache. It's not something you need to worry about if you're just using Lexical iOS, but to understand what's going on behind the scenes, it's helpful to know what it's doing. To understand why the range cache is necessary, let's return to the difference between Lexical Web and Lexical iOS. On the web, Lexical's reconciler is applying the changes from one tree structure, the node tree, to another tree structure, the DOM tree. Lexical just needs to keep a one-to-one mapping for which lexical node corresponds to which DOM node. But when working with TextKit on iOS, we're not working with the tree structure. We need to output mutations on string ranges. String ranges are tricky because even if we know which range corresponded to a certain lexical node, that range can change if some text is inserted or deleted earlier in the document and our node is no longer in the same position. Therefore, Lexical iOS keeps a canonical single place to store the string ranges corresponding to each node. We call it the range cache. We update the range cache as part of running the reconciler, and we make sure to update every node whose range is affected by the change. This will not just be the nodes which are themselves dirty, but it will include every node later in the document. The reconciler reads from the range cache when deriving the insertions and deletions that are needed, and it updates the range cache afterwards, so that everything is in a consistent state, ready for the next update. Next up is transforms. While developing Lexical early on, we noticed that it was common to want to do an update based on another update. For example, if you wanted to style a hashtag in a certain way, you could build a hashtag node. Then when the user types a hash symbol, you want to turn it into a hashtag node. But in order to do that, we have to wait for Lexical to finish the update, and then in an update listener we have to go read the new state, go through all the nodes to find out which ones have hash symbols, and change them into hashtag nodes. That's not very efficient, nor is it easy to code. So we introduced transforms. You register a transform on a certain node type that you care about, and you pass in a closure. Transforms run during an update, after the update closure has been run, but before the reconciler. At this point, we have a list of all the dirty nodes. We then check all the registered transforms and call any that match the node type for the dirty node. Each transform then gets a chance to manipulate the editor state before the reconciler is run. So in our example, we could check for the presence of the hash symbol in the dirty nodes, which is much more efficient than having to check the entire node tree. If we find the hash symbol, inside of our transform, we can swap out that node for a hashtag node. There's all sorts of other things you can do with transforms. They're useful if you want to validate the content the user can put into the document, or which formatting the user is allowed to use. For example, if you wanted to disallow bold text, but you didn't want to go to the trouble of subclassing text node, then you could build a transform where you check to see if the dirty node is bold, and if it is, you just set it back to not bold. Let's move on to listeners. Listeners are callbacks triggered on internal lexical events. One of the most common types is an update listener. That's simply some code that gets run after an update is finished. Unlike the transform, which is run partway through the update listeners are run at the end of the update. They're useful if you want to do something whenever a change is made. For example, if you want to immediately persist the data. Or maybe you want to update your user interface to enable and disable the appropriate toolbar buttons. Just make sure your code inside the update listener is fairly lightweight, as they'll get run on every keystroke. Finally, commands. These are our abstraction over the platform's events, along with various other internal lexical events. You can also write your own commands for any events specific to your plugin. The great thing about commands is that your plugins can also intercept them, and we have a priority system for overriding Lexical's own handlers for the commands. For instance, if you want to control what happens if a user taps a link within the document, you can override the link tapped command. And in your override, you have access to the URL, and you can do whatever custom logic you like. Finally, you can return true if you have handled the URL, or false if you want to allow Lexical to continue handling it with the default behavior. Last but not least, I'm going to very briefly go over how to start integrating Lexical into your iOS app. This isn't intended to be a full tutorial. For more information, watch the session on the selection and building toolbars, or take a look at the code for our Playground example app. Lexical has two different front ends, Lexical View and Lexical Read-Only View. For most purposes, Lexical View is what you'll want to use, so that's what I'm going to talk about here. To set it up, you initialize the Lexical View with an editor config. This editor config is created with a theme and an array of plugins. If you do not want to use any plugins and you're happy with the default theme, then this is all you need to do. You can then drop the Lexical View into your view hierarchy, and you've got editable rich text in your app. Note that Lexical does not come with a toolbar. Recall that I said Lexical is a framework for building rich text editors. We operate on the philosophy that the toolbar and UI for Rich Text Editor are so tied to your app's user experience that we don't want to provide a one-size-fits-all solution. We have a whole session on building toolbars, and you can also take a look at the toolbar plugin from the Playground app. This is an example of a toolbar, rather than something that we intend you to reuse as is, but it could provide a good starting point for your toolbar journey. Once the Lexical View is inside your app, you probably want to do things to it programmatically. Most things in Lexical start from the editor. You can request the editor that is attached to your Lexical View, and use that to do all kinds of things, from registering new listeners and commands to performing updates. This code shows how to call an update that appends a paragraph at the end of your current Lexical document, for example. See how we requested the editor from the Lexical View and then called update. And then within that update block, we can use the Lexical API. Again, I suggest you look at the Playground for examples of how to use lots of Lexical's features. For example, you can learn how to serialize Lexical's data model to and from JSON. Additionally, take a look at all the other training sessions. We've got a few out now, and more coming soon. We also have some great documentation explaining many of the concepts and APIs. Finally, here are some links to the Lexical iOS GitHub, the documentation, and to our Discord server, which is the best way to communicate with our core team. I hope you enjoy using Lexical, and I look forward to seeing what you create.